Diodes can also be used as rectifiers. To rectify means to straighten out or make straight. So we will start with a alternating current waveform. In this case, it's shown as a sinusoid, and its graph is shown right here. Notice that it goes above and below the axis, so it's positive for half a cycle, negative for the other half cycle. What we'll do is when the sine wave is at its positive side, it will start a conduction through the diode, which acts as that one-way valve through the resistor, in this case we call V load, and we will get the first half wave. However, when the sine wave is negative, there is no conduction because the diode is reverse biased, and we'll end up with 0 voltage there, having to wait again until we end up with the additional second peak. So this is called a half wave rectifier because we are only straightening out or using half of the waveform. We have another example of a full wave rectifier where now we have two of these sources, one here and one there. Typically, instead of having two sine wave sources, it's really two separate windings on a common core of a transformer. But it works the same. Let's take a quick look. So here is our sine wave going above and below the axis, so it's positive for one portion, negative for the other portion. What happens is that during the positive portion of the wave, the upper diode here turns on and runs the current through our load from the positive to the negative direction. So we can see that happening right here. Then, when the sine wave is negative, we end up with the other diode turning on because it is now positive in this sense. And again, we have the current flowing in the same direction through the load, and we end up with what we call a full wave rectification. This is sometimes also called a split phase rectification, but the idea is we are able to use both the positive and negative peaks of the sine wave and put them both of them above the zero axis, so we have nothing but a positive voltage. The diodes alternately turn on, one then the other, for each half wave. Another way to get a full wave rectification is what we call a diode bridge or full wave bridge. This one has a single source. Again, we show it as a sine wave, and again it goes positive, negative, positive, negative. But in this case, we have four sets of diodes in kind of a diamond shape that we call the bridge. When the source is positive, we can follow the current through the A diodes, through the load, and notice that we're going to be running two diodes here in series back to the load. And so that gives us the positive waveform here. However, when the sine wave becomes negative, the current flows in the other direction, and we will go through the B diodes, again in a positive direction through the loads, and once again back to the source. So in that case, when the sine wave is negative, the B diodes turn on, and once again we have both the positive and the negative peaks of that sine wave are now rectified or turned positive, so we get to use both positive and negative peaks, and this is another example of a full wave rectifier.